One common question I often get asked is about the Maximo Application Suite, high availability and disaster recovery architecture. So today I have decided to tackle this topic and share my own perspective on designing an effective HA and DR system for MAS. In this video, I'll be discussing one of the most reliable MAS HADR approach on AWS using DB2 Standard Edition database. It is important to note that this approach can be applied to any hyperscaler and any database. You just need to adapt some of the technical terms with respect to the platform you are using. So what exactly is HADR mean? HA stands for high availability and DR stands for disaster recovery. While they are often mentioned together, they are not the same and serve totally different purpose. High availability is a system design and architecture function that is carefully tailored to enable a system to detect the failure of one or more its components and take necessary action to continue serve its purpose without any degradation or interruptions, allowing the system to auto-heal or request human intervention to heal the failed components without any system downtime, ensuring that all components are brought back to a healthy state. So HA doesn't mean 100% service availability. High availability design improves the degree of availability to the maximum percentage. So HA system design is a approach where you increases the chances of services availability. It doesn't guarantee the 100% system availability to the end user. HA systems uses a variety of strategies to achieve their goals, including redundancy, failover, virtualization, and clustering. In the case of MAS, we will be discussing the clustering approach, we will be discussing the failover approach, and also the redundancy approach. Virtualization, by default, when you use the OpenShift orchestration platform, we are using virtualization, we are using clustering, we are using failover, and we are using redundancy. So the orchestration, the OpenShift platform by default gives you HA. That's the whole purpose of having a orchestration platform and the containerized application approach that MAS has adopted. Before we go review the architecture design for MAS HADR, let's understand some of the enablers of HA and DR, namely the region and availability concept in the hyperscaler world, or the cluster across box CAB in case of the on-prem. So the concept of region availability is pretty simple. Region is a cluster of data centers in a specific geographical area. Availability zone or AZ is within the region. So normally a region can have multiple availability zone as I have shown in the diagram, and the region 1 has 4 availability zone. Each availability zone has its own cluster or database. In case of availability zone 1, you can see I have 3 data centers. In case of availability zone 3, I have single data center. Similarly, I have region 2 here with 3 availability zone, and each availability zone has cluster of data centers. So in case of the cloud, we pick the region and we deploy our compute or our cluster resources across availability zone. That is the whole idea of HA and DR. In case of DR, we pick 2 regions, region 1 for your primary and region 2 for your secondary, which is a DR cluster. So here in this case, you can see the region 1, I may distribute my worker node across multiple availability zones. So that is the enablers, what I call enablers for HA and DR, which is a region and the availability zone concept in the case of cloud. In the case of on-prem, it's a little bit different. That is the cluster across box concept. In the next slide I'll explain that. Before I go to discuss the cluster across box concept in on-prem, there are few other concepts in AWS case. Similarly, we have Azure and Google. There are their own technical terms for each of these components. We have the AWS local zone, which are extension of a region. So local zone let you choose more specific geographic location such as Boston, Los Angeles, Dallas, etc. They are not designed to increase workload redundancy. Their main purpose is to boost performance by hosting workloads in a specific area. They are not meant for you to make one of your worker node there and deploy the ports accordingly, or make the cluster across local zone. They are just there to increase the performance of your service. So do not try to deploy your cluster in local zones. Another concept is the AWS wavelength zone. Wavelength zones are AWS infrastructure hosted on your telecommunication providers data centers. As an example, if your ISP is Spectrum, they have their own data centers, and the wavelength zones are where some of the AWS infrastructure is hosted directly on the ISP providers infrastructure. Their whole purpose of there is to minimize latency for workloads that need to connect to mobile networks. So basically they are used for mobile traffic. Suppose if you have an IoT application that communicates through high-speed mobile, you can use the wavelength zones to improve your performance. Another concept is, but again, wavelength zone is not used to deploy your workloads as an HA concept or DR concepts. They are totally different purposes. Similar to wavelength zone, another concept is AWS Outpost, which is extending the AWS infrastructure into your on-prem. Which another term for is hybrid clouds for deploying services at customers on site. Workload loads hosted on Outposts are linked to a region and availability zone, but because the workloads don't reside in AWS data center, you don't get the same availability guarantee that come with standard availability zone. So there is a guarantee, availability guarantee for each of these availability zone, 99.99% available. But that is not available for if you extend the infrastructure to your own site using the AWS Outpost. So now take a look at the on-prem deployment of HADR. So on-prem we have the limited hardware capacity, but it depending upon how large your data center operation is run for a customer. We have the more flexibility and scalability like the hyperscaler. The same automation, the infrastructure as service operation can be run on the on-prem data centers also. So everything depends on how mature your customer's data center operation is. But to understand the whole concept of high availability within an on-prem case, you can see in this diagram I have a small on-prem data center with the 3 racks, rack 1, rack 2 and rack 3, and each of the rack I have 6 servers, physical servers. So I have 18 servers on the total. I have total 18 physical servers available, and as you know, normally we spin off VMs out of these servers, so I can have 3-4 VMs running out of this individual rack server, and another 3 or 4 from here, so I have 8 servers here. So the idea here is to make sure your cluster worker nodes are distributed across servers and across racks. So the concept of cluster across box means you shouldn't end up when you define a cluster, when you deploy the worker node, all your worker nodes shouldn't be ending up in single server, right? Instead of that, you need to make sure they are distributed across the boxes. Like in this example, I have the worker node 1 in server 1 and worker node 2 in server 3 and worker node 4 in rack 2 server 4, right? Similarly, you need to make sure the distribution happens. Why? Because in case you lose this server, the server 1 on rack 1, you still have the worker node available in same rack and server 3, right? Or in the case of the whole rack, the power to the whole rack is lost, right? Then the whole rack is gone, still you have 3 worker nodes available on rack 2 and rack 3, right? Total 3 worker nodes. And what happened? The orchestration framework sees that we don't have the enough ports or worker nodes available, and using the autoscaler feature, you can have additional worker nodes automatically spin in rack 2 and rack 3, or when the rack 1 comes back online, we can move those VMs back into rack 1. So the OpenShift takes care of port management based on the user loads or the request coming into the pod, but you need to make sure your worker node deployment is distributed across the box. So this is for HA. Same concept for DR. If suppose the customer has only one data center, we have to rely on the same mechanism where you distribute cluster across box and cluster across racks. But if you have 2 data centers in region 1 and region 2, and if there is a high connectivity between them where you can send backups into this data center 2, you can use the secondary data center to deploy your DR cluster. Similarly, on the secondary data center, you have to do the same architecture concept where you deploy your worker node across box and across racks. Now let's take a look at the MAS HADR architecture itself. Here you can see that I have deployed an HADR cluster. I have a availability cluster here in region 1, which I call a primary region. I have a DR cluster running in the secondary region. Each region I have 3 availability zones, AZ1, AC2, AC3 in primary, similarly A1 to 3 in the secondary region. You can see I have a cluster running on my primary region, a single cluster, 3 master node and 5 worker node deployment. I have a OCP cluster in the DR running, which I have the 3 master node and 2 worker nodes. So DR is 50% capacity compared to the primary region. So there are concepts of active versus passive cluster deployment. That's a totally different topic that I need to discuss. But here we are just merely focusing on the active deployment of a MAS cluster. But there are other things that you can do to reduce the cloud cost or your compute cost, which I will discuss once I explain all these components shown here. So in my primary cluster, as I mentioned, I have kept my master node in 3 availability zone for high availability. That means if the one of the master node fails, or I lose this availability zone. Remember, availability zone means a single availability zone can have multiple data centers or single data centers, right? It's a cluster of data centers connected with the high speed network. So I do not know where my compute instance is running within that availability zone, right? So either I can lose a data center, and I'm lucky that my server is running on that data center and I lose that master node, or the availability zone is available, I lose one of the data centers, still it's not affected me. But there is a case if I lose the whole data center in that availability network, right, then the whole availability zone is missing. But in my case, since I have a redundancy here with M2 and M3 deployed in AC2 and AC3, there is no issue. So this is the whole concept of HA, right? So if you remember, OpenShift is built for HA, right? So it gives us the cluster capability, right, where you can put your cluster node into different regions and availability, either is cluster across box or cluster across racks, etc., right? Similarly, we have put our worker node distributed across availability zone to make sure the issue with a specific availability does not impact our application, right? But if you remember, the OpenShift actually can scale your ports, right, depending upon the user request or the how much work load is on a specific port. They can do that. Similarly, you can also auto spin or add worker node by auto scaling. You can scale based on your node. That means if there is not enough capacity for your pod scheduling, yes, you can automatically add worker nodes, right? Or you can go manually add scale up, right? So if you see that you lose your data center availability zone 1 and your cluster is struggling a little bit degraded before it's become too much problem, right, OpenShift will try to spin more pods into worker node 3 and 4 5, but to ease that load you can go actually add worker node, additional 2 worker node here on the availability zone 2, right? Now we have only 2 availability zone, but still the service, there is no degradation of services or there is no performance issue, right, because still is running between these 2 availability zones. And remember, your load balancer is sitting outside above or your all region, right? So it's always available. So the availability of having an issue with the AWS load balancer is very rare, but it can happen, right? Everything fails for sure. So here in this case, so we have the high availability use based on the distributed deployment across the availability zone, and we are strategically putting all these worker master node accordingly. Same approach we have taken here on the DR region 2, right? We split them distribute them across availability zone, but this is not an active, this is a standby, hot standby we call, right, cluster. That means it is, you can we can put them in 2 master node 2 worker node combination to just minimally run that application, right? At least the OpenShift is up and running, right? And once if a DR situation happens, right, you can actually scale your DR cluster to match your primary region so that the same amount of customers are get the same performance that they used to get from the primary region. So it's a totally seamless in that case. But some customers do not want to scale 100%. Since they are DR, they are okay to be 50% capacity, right? But their aim is to go back to the primary region as soon as possible and become 100% capacity, right? So it's a strategy that you have to work with your customer. What is your secondary capacity that you need, your DR capacity that you need, or there is a strategy that you put, oh, if I can go back to your primary region within 8 hours, there is no scaling needed. But there is an outage for a whole region happened, and there is the response or recovery time or the resolution time is more than 48. Yes, I need to scale my DR to match my production. So it's a DR runbook that you have to define all the strategy, and based on the event you have to respond accordingly. And all these scaling, scale up, the movement, everything can be automated using scripting, Ansible, Terraform, whatever you write the scripts, you can automate that. That's all about the OpenShift piece for HA. By default it provides. Only thing you have to make sure you're properly distributing your master node, worker node. So that is taken care. Now the major complex piece is the data, right? So in this example, I have kept my database external to the cluster. If you're DB2, you can run your database, your DB2 database within the cluster. That means the DB2 pods are running in one of these worker nodes, right? And you can scale pods, right? So that way you can have HA available, high available HA within the cluster. But in this case, I have kept my database externally, right? Within the same AWS infra, within the same region, but externally I have a dedicated server for that. So in this example, I have a primary database server and a primary disk. I have a HA database server and HA disk, and you can see that instead of keeping HA data on the availability zone, I have purposely kept it on Z3. availability zone 3. Reason why? Because if I lose H availability zone 1, I can fail over to my HA database, right? How that failover happens, that is a configuration that we have to do using in case of the DB2 we can use the pacemaker cluster. So pacemaker is a piece of software that enables DB2. It's part of DB2 standard and advanced edition. So pacemaker can be used to create a cluster which is between primary and your HA database, and it can detect any issue to your primary database and automatically fail over to HA. That means it take over the primary responsibility from the primary disk. Either it's a local server issue or the whole availability zone issue, it automatically fail over to HA, and HA will take over and will become your primary. But if you remember the application, the JDBC URL, in normal case we point to an IP address or a domain name for your database server. In a HADR case, you have to make sure you use overlay IP. To discuss what overlay IP, how it is configured, that's a little bit complicated topic for future, but just you need to understand it's like a common name, right, which sits between primary and HA, right? So it's a common entry point into the pacemaker cluster. So that's the IP address or the name that you're going to use. So it doesn't matter whichever the disk, whichever the server active, the cluster doesn't have to worry about repointing to the specific database server, right? The pacemaker cluster does the whole job. So in case of the primary fails, this will take over, this will become the primary, and the whole transactional activity is seamless with respect to the customers or the end users or the cluster itself. So you won't even see a flip in the manage or even in a session out or anything within the manage application if the pacemaker is triggered a HA event, right? So that is HA using the pacemaker cluster. Oracle or a SQL server, that we have to use a totally different approach. This is based on DB2 pacemaker integrated software component. In the case of DR, in this architecture you can do DR in the same region, but it doesn't make sense. But if you choose you want a DR, okay, of course you can take the availability zone 4 and availability zone 3 to make your DR within the same region, right? But doesn't really make sense to keep your DR in the same region. What if happens, what if the whole 3 availability zone or the whole region is lost due to something, right? In that case, your whole application, you don't have a way to bring your application or provide the service the end users need, right? That's normally DR is kept in a different region. See here, the region 2 is for DR, right? So you have to configure your database so that when the DR happens, one of these database, so here you can see the aux1 and aux2, right? This is auxiliary 1 and auxiliary 2 databases. It's a HADR configuration that comes within DB2, where when you set up the HADR configuration, you can say this is my primary, this is my auxiliary 1 and auxiliary 2 databases, right, along with HA. So when you configure the aux1 and aux2, you can define which of them you're gonna make primary in case of a DR event. So when you fail over to a DR, of course there will be an outage, right, for sure, because you have to make one of these database as active. Normally in an HADR configuration, the auxiliary 1 and auxiliary 2 is called ROS database, read only standby active primary databases, sorry, DR primary databases, right? This is the only database that is you can actually transact. Only one database at a time in a cluster that can be active, right, where you can have read write activity. All the remaining database is read only standby databases. In case of HA, of course this will become primary and it will become read write. This will be go to a standby, right? If there is a problem, you can fix that database and bring that as a bring back to the cluster as a HA instance. So in the DR, as I mentioned, we have the configuration that comes with the DB2, where you can define its two auxiliary nodes, primary and secondary, and there are various syncing mechanism, right? It's like change data capture. Whatever the transaction happening in the primary database will be shipped or synced into these two databases, right? So there are different mechanisms, near sync, real-time sync. There are different DB2 variants of syncing, how the sync is going to happen from these two databases. So there are best practices around which method you need to use, right? So again, that is another different topic to discuss, but you can set up the syncing mechanism for from your primary disk to the auxiliary 1 and auxiliary 2 disks. Also, the timing of syncing also important. So when in the case of an event, right, in a DR event, what happens, suppose you have this DR primary is the defined primary database. That means you define that if a DR happens, I'm going to make my aux1 as primary, and I'm going to make point my manage or application into this disk, right? So this can be on a lower delay sync. So there is ideally it's good to have a delayed sync in case if there is a transaction if it happens, you can actually go revert them, right? So there is a delay is always good, say a calculated delay, I would say, right? So I can say this DR primary will be a 30 minutes delay compared to your primary. You don't need to them a close sync, right? At least 30 minutes good. Similarly, I can say this may be a 90 minutes or 1 hour 60-minute delay in aux2. So when a DR happens, right, so you lose this whole region, you fail back. Now your database is either 30 minutes behind, right? So that is where you have to make sure you have the transactional log that can be captured and shipped to the secondary region, and that can be applied to bring the database back to the closest transaction. Is called RPO, right? You have the RPO and RTO defined, so you need to bring your RPO closest, right? So that's where you apply your transactional log to bring the database aux1 to the best level. In case if you are not able to bring DR primary as active due to some reason, right, you have another database as a backup which you can make primary. That is the purpose of this secondary database. You can have just single database if you want to cost cut and take some risk, say that okay, I am 99% sure if a DR happens, okay, I'll be able to bring this up. But a best practices is to make sure you have another copy in another zone, right? You can see aux2, I call it as a reporting database. It can be used for reporting purpose to pull data, but this is also a guarantee for me in case I have some issue with aux1, I can use aux2 to connect my database, connect my application. So looking back to the whole database cluster configuration, just want to go back and explain one more time. So we have the database servers distributed across multiple availability zone across regions. We need to make sure the database server does not end up in the same availability zone. We have one primary database which is active, where the transaction is happening, and the Maximo, the manage is pointed, or the MAS cluster is pointed. We have the HA database, which is a read-only standby database, which is made up of a pacemaker cluster. Pacemaker cluster is a cluster manager software which is integrated to DB2 standard and advanced edition. So you use overlay IP there to switch back and forth between primary and HA in the case of an event, HA event. Now also we have under the HADR configuration, we have auxiliary 1 database and auxiliary 2 database. We can have one database if you need, but as I explained earlier, aux2 is a double guarantee that if in case aux1 we have issue, we can make them primary. So in the case of DR event, we need to make one of these database active and primary. Then you can point your cluster MAS core JDBC connection to one of these database which you made primary. Based on RPO, you need to make sure, depending upon the failure time, you have the archive logs available, so that you can apply those archive logs once you make this database active to bring your RPO closest, right? So the best practice is to make sure the archive logs that is getting generated on the primary is shipped into using a job or anything, you ship into a secondary region, so it's readily available here. You can use do that by actually replicating your disk. If you are using EFS or EBS, you can actually replicate your disk to another region, and even though it's read only, once the DR happen, you can actually get your archive log quickly there in the secondary region, make this database active, apply the archive logs, bring back the application. Simple. I explained the OX2 database is OX1 and OX2 is again ROS read-only standby databases when in a normal running situation, and that can be also used as a reporting database. That means users can connect, or tools can connect to those databases to pull information. You cannot transact, but you can read data from here. But you need to be careful putting people or tools access into HA. Remember, HA also is a read-only database, right? You can provide your users access to query them, right? This is a real-time database. This primary and HA is syncing in real time. OX1 and OX2 is not real time. It's close to real time. How much delay you want, right? So you will have a calculated delay between your primary and OX1 and OX2, right? For purpose, it's a purpose-made delay. HA is real time, so if you have people, instead of giving them directly access to the primary, you can give them to access to HA, but you need to be careful doing so, because in the case of event, in the case of a HA event, right, this will become a primary database, and now you have the application and the users at the same database, right? So either you shut them out of the HA during an HA event, or move them to one of these OX databases, or the best practice is to have a replicated database external where you put all your reporting users and reporting tools connected outside this cluster or outside this configuration. So in summary, HA is a seamless and no downtime required for HA. So both database can be primary based on the situation, or where the issue happens. If the primary fails, HA will take over. So HA is seamless and no downtime. DR will have downtime, and the length of downtime depend on your DR setup, like active, warm or hot standby, etc. Those are the DR concepts. So it depends on that deployment, the length of the RTO right defines. So if you have a 24-hour, you don't need a DR, right? If you have a 24-hour downtime, you can actually deploy your cluster, you can install your Maximo, bring the backup and configure. So there is no DR. It's all you can build during runtime. If it's not a mission critical systems, right? If it's a mission critical system, it's good to have a warm standby cluster ready for you to run, right? So that's why earlier said it's all strategy, how you define your active or warm standby, etc. Pacemaker cluster and overlay IP configuration enables database HA. So this is what enables database HA. The OCP OpenShift Container Platform multi-availability zone distributed deployment enables the application HA. So here you can see we have a multi-zone distributed deployment that by default provides you the application side HA, and the pacemaker cluster here giving you the database level HA. DB2 provides multiple sync options from primary to OX1 and OX2. If you remember, I talked about this primary syncs with these two databases. So you can see there the load on primary is a little bit high. It has to sync with HA and OX1 and OX2. That's why there are two different mechanisms on the sync without impacting any performance impact to the primary. Namely, we have sync, near sync, async, super sync. These are the options. So depending upon this configuration, the transaction will execute on primary, right? So there are options where you can say, okay, if a transaction happens on primary, I want the transaction to be committed on the aux1 first, then come back and commit on primary, right? So those kind of sync options we have, but that's a performance issue because it has to wait for aux1 to complete the transaction, give a signal back to primary, then perform the commit, then only Maximo will get the control back after the transaction commit, right? But there are configurations where say, okay, I don't care whether this commit happens on any of these databases, as long as I get the data here in the primary, I commit it, but I will issue a signal to the DR primary and DR secondary that this transaction happened, and I send that data for them to sync it, and it's up to them to sync and keep up to date with the primary. So those are the options DB2 gives, which I mentioned: sync, near sync, async, super sync. I'll make another video where I explain each of these options and what it does. Archive log shipping, as I mentioned, is very important, right? You need your archive log to bring your the aux1 and aux2 to the latest level, right? Without archive log, you will be behind 30 or 60 minutes behind of your failure data. So based on your RPO requirement, you need to make sure the archive log is either backed up to a different to the DR region, and it's accessible to the cluster, the DR site, whenever a recovery needs to be executed. So all these DR strategy needs to be a playbook based on situation. You need to define if it is a non-DR situation, that means you don't have a cluster, you have nothing on the DR region, just the framework available, because you don't want to spend cost on this compute running, right? That time you have a playbook which exactly says how to install OpenShift, how to deploy, how to get the backup, how to set up the database within this 24 or 30 hours period of time. So that playbook 1. Playbook 2 is for warm standby, where you have the minimum cluster size cluster running, and you don't have a mass manage application available, right? You go deploy when in the case of DR, or you have a mass core deployed, you don't have manage, you just deploy manage, right? Another variant is you have manage, but it's turned off, it's not active, right? So you can, based on your requirement, you can define your strategy, how you're going to play on the DR side. So in the next slide I will explain some of the strategies that you can apply based on your customer need, which will reduce your RPO time. So now just let's take a look at the DR strategies. Some of the key strategies I have detailed here, 1 through 5. The first strategy is backup and restore. This is the simplest strategy. In this strategy, you do not have a DR, right? You have a DR site, you have nothing configured, there is no cost involved here, right? All you are doing is taking your data backup, taking your application configuration backup, and during a DR event, you have enough RTO time defined, RTO and RPO time defined to build up this environment. So if you have a Maximo Application Suite like application where you have the automated deployment, this is the best strategy. You don't have to spend that cost, but you are not having a real DR environment to do a DR exercise, right? So even in the backup and restore, during the DR event you are actually building the environment ground up based on the backup and the backup configuration backup and data backup, right? So as a strategy, you have to make sure you do this exercise to rebuild the environment yearly once, so that when in a real event your team is capable to do that within the defined RTO. Another option is Pilot Lite, which means maintain a minimal version of your environment that can quickly scale up in case of disaster. This one I really explained when I was talking about the architecture. So as an example of a Pilot Lite or DR strategy, you can have your OpenShift cluster available with just 2 master node, single worker node, nothing is deployed, right? And in the DR event, you're gonna scale up your OpenShift cluster first, 3 master node, 6 or 7 worker nodes depending upon your cluster sizing. Then you're gonna start installation of MAS core. You are going to install your manage and all the related suite application. And also you're gonna deploy stand up your database server, or in the pilot you can have the HADR for data available, right? So that time is saved. So you have the database and data is available. Only thing you have to make your aux1 active, right? And you just build your application and scale it up. Another option is warm standby. Keep a fully configured environment running at a lower capacity. That means you have that was example in my architecture, that was an example, right? Where I have the OpenShift cluster, I have the MAS core installed, I have the manage installed, everything is running, but it's a very scaled down version of it, right? And I install manage and I just turn it off, right? It's not even, manage is not running, but I have the manage deployed and turned off, right? So now when a DR happens, only thing I have to do is make sure I make my aux1 active, right? And apply the archive logs to bring it to the latest level based on the RPO, latest level defined by the RPO. Then all you have to do is activate your manage, enable your manage, because manage is already installed. That is warm standby. Active is the complex configuration, I would say in case of MAS, because here you are saying you are running the primary and secondary region and your cluster is across, right? You have deployed 2 clusters, you have a load balancer which is kind of distributing your traffic between these 2 regions. And the complexity is how you're going to configure and set up your database, right? That's a complex, but it's a possible architecture. Then multi-region active, passive, again it's the same concept as warm standby. You have the all traffic going to your primary region, the secondary or region or DR region is passive. That means when needed, right, you can either use the warm standby or Pilot Lite passive design, and you can scale up and bring that cluster back up, right? And then after that is done, you route all your traffic into your DR region. So these are the 5 major approaches that you can major strategy or approach that you can use to have a discussion with your customer and to understand what best fit for them. One important thing I always bring is the DR playbook or run book, right? Because this is a complex setup. So your team need to do exercise, right? You have to have DR exercise yearly once or half yearly to make sure team is well versed based on the strategy you have. In active you don't have to do that because your traffic is anyway split between these regions. But the backups and restore is a complex one, time consuming, not in the complex in the sense, but it's more time consuming. You have to build everything. Warm standby and pilot is a little bit lighter because you have the infra and major components are readily available for you, right? So depending upon that, you define your strategy and you can deploy your HADR concept for or HADR setup for your MAS. So that's pretty much I have on this MAS HADR deployment architecture. We have to acknowledge that this is a bit complex topic which needs deeper conversation. But I hope this was helpful to wrap around some of the foundational concepts and best practices. Please leave your comments and questions, and thank you so much for watching.